So hello everyone, this is Balkrishnan, and today we are going to discuss about the automotive product design, automotive plastics specifically. So when we are designing the plastic parts, right? So everyone, like most of the students know how to design the automotive plastic parts, right? So when we are designing the plastic parts, okay, so here I have some of the plastic parts, right? So you can see this is a pillar part, or we have a door complete, right? So, or we have this part, right? Or we have fog lamp part, right? So these parts, whenever we are designing, the basic things what we are going to understand is that first we require a classic surface of the part. So classic surface means what? If you see this is the aesthetic surface, visible surface of the pillar, right? So this I am calling as the classic surface. So we are creating the first body, right? Solid body, closed body, class A, class B generation, class C generation. We are joining and we are creating it in CAD. Okay. So, from manufacturing point of view or from design point of view, right? The solid body is important, and solid body plus the features are also important. So, in the door parts also, if you see here, we have a complete door, right? So, in this door also, this is the aesthetic side of the door completely. Okay. Aesthetic side means visible side, and this is the non-visible side of the door. You can see this is completely the non-visible side of the door. Okay, we are calling this, all the things are b-side features, right? So aesthetically it looks nice visually, right? But whatever this b-side attachment, this is completely the engineer, right? So this we need to understand when we are designing the any plastic parts. Okay, so the feature study or b-side feature study is very important in the automotive plastic part. You want to work onto the actual parts, right? So these complete features, right, one by one we need to understand first how to design, what is the process, what is the functional dimensions. Okay, so every feature having its own requirements. Okay, so let's suppose we have an assembly feature called a snap, right? So snap we are using for the fixation, right? Like for assembly of two plastic parts. Here I am assembling this map pocket with the door trim part, lower trim part. So here we are using, or we are assembling it with the snap. Okay, so snap we are using as a temporary or permanent fixation, right? That we need to decide. Or other features also, you can see we have lots of features. You can see here welding bosses. Okay, welding bosses we are using. So welding bosses we are using for the permanent fixation, right? So two plastic parts we are permanently fixing, like that. So lots of features are here. You can see the let's suppose dog houses. Okay, these are the dog houses. You can see this dog house, this dog house. Okay, here also we have a dog houses. So here this dog house is why we are creating. Okay, so something, the retainer pin is coming. So this door we are assembling onto the BIW panel, right? So that time there we are inserting the pin, right? And then plastic to BIW when we are assembling, that time that dog houses will use. Okay, so every feature having its own meaning and own requirement. Okay, so if you see some of the features, like let's suppose you can see here, this is the snap feature. You can see this is a snap with the doghouse. Okay, so you can see this is doghouse is created, and above that the snap is mounted. Okay, so like this, or screw boss is there, right? Screw boss is mounted onto the doghouse. So this type of feature we are creating. Then in the tooling, how we are creating this. So if you see in this feature, we are clearing this feature from this side, this direction, right? So this is what I call as a, here we can use the slider, right, instead of lifter. So slider lifter concept also you should know. Okay, what is slider, what is lifter, where to use. Okay, so every part having a different features. Here we can see we have a clip towers. Okay, so this is a clip, right? It's a plastic clip is mounted onto the clip tower. If I remove it, this is a clip, you can see, right? So this is a plastic clip, right? And this is a clip tower is created, and clip tower is mounted onto the, again, onto the doghouse. Okay, so now this undercut, we have this undercut constraint, right? So here also we can see the undercut, or here also, so every feature having an undercut. Okay, so now how we are clearing this feature into the tooling, that is also important. Okay, so this is also, we can say, the clip tower, dog houses. Then reefs we have, we can see the reaping structure. This is we are calling as honeycomb structure of the reefs. Okay, you can see this is a honeycomb structure of the reefs. Okay, then we have We can see the brick structure ribbing. Okay, so brick structure ribbing also we have created here, you can see. So these common features at least you should know when we are working. Okay, common features also every part you can see this is a B side of the non-visible side of the part. So common features you should know. Okay, so whenever you are designing the plastic part, any plastic parts, okay, so aesthetic is important, as well as the B side or this B side attachments are very important. So whatever features like snap we have, then we have dog houses, we have locators, right? We have clip towers, we have reeving structure, we have retainer pins, right? Or other features also, right? So this all the features you can learn first. Okay, what is the functional dimensions? Functional dimensions means what? Functional dimensions means any feature whenever you are designing. Let's suppose here we have a snap feature. So snap feature, how much the maximum width we can keep, how much the total height of the snap we can keep, how much the angle. Okay, that is also important. So these also you need to study from the engineering point of view. Okay, so these all the points are important. So next time whenever you are working, right, in on any automotive plastic, right, automotive product or automotive plastic, so observe these parts, observe these features. Okay, how this part is assembling onto the another part, that is very important. So by physically you can understand more instead of design we can understand, but you are not coming, you are a fresher, let's suppose. So physically if you are observing these parts, right, so you can understand better. Okay, so these B side attachments, whatever you can see, okay, that is very important. Okay, here also what I discuss is the honeycomb structure ribbing. So why we are providing here honeycomb structure, why not other ribbing structure? Okay, that is also the question, right, that you should know, like what is the answer. Or when we are going for further process, okay, like B side attachment, then material selection, then undercut removal process completely, then assembly, like how these parts are assembling with each other. So for that we are using the RPS. Okay, so what is RPS? Then section study is also there, right? When we are designing master sections we are creating, right? So this all points are important. It's not just about the closed body creation like class A, class B, class C. So many students claiming that they know the automotive plastic product design, they know only the closed body creation. So it's not about the closed body creation, it's all about complete engineering. Okay, from the material selection to the assembly of the part to the completely design of the features. Okay, placement of the features. Then cap and flush concepts are there, lots of concepts are there, defects removal is there, right? Or where to provide a shut off angles. So lot of this concept you need to understand from the basics, from the scratch. Okay, then you can start practicing like a simple part design. Let's suppose we have this type of cup holder part. Okay, you want to design this cup holder. It's a very simple part. Okay, so very simple part means we can see this is very basic part, right? Here we are putting our like this holder type of, we are putting our coffee cups or anything, right? So this part also very simple. It looks very simple, but for designing also complete engineering knowledge required. Okay, like a material, then complete function of this part. Okay, where this assembling, right, surrounding data you required, then how we are going to assemble. Okay, where I am going to mount this, I'm going to use here screw bosses, what I'm going to use. Okay, that is also very important. Okay, so next time when you are designing any plastic part, okay, so design or think about complete engineering, not just focus onto the CAD. Physically go and watch how these parts are assembling. Okay, so from interview point of view also you can understand or you can get this knowledge and you can answer better.